Welcome to the video for C5.14, where we're going to look at concentration of solutions. So what we need to be able to do is we need to know that we can measure the concentration of solutions in two units, either grams per decimeter cubed or moles per decimeter cubed. We need to be able to convert centimeters cubed and decimeters cubed in between each other. And then we need to be able to calculate concentrations in moles per decimeter cubed and grams per decimeter cubed. So how do we work out concentration? So there's two formulas for concentration. So if it asks you to calculate the concentration in moles per decimeter cubed, then it's simply the amount of substance in moles divided by the volume, which has to be in decimeters cubed. So the clue for that, if you can't remember the formula, is to look at the units. Because if the units are moles per decimeter cubed, then that's the number of moles divided by it, and decimeters cubed is a unit for volume. And then if we're doing it in grams per decimeter cubed, then it's simply the amount of substance in grams divided by the volume in decimeters cubed. So it's always in decimeters cubed. The difference is whether it's in moles or grams. So first thing we need to be able to do is convert from centimeters cubed to decimeters cubed and vice versa. So 1 decimeter cubed is 1,000 centimeters cubed. So if I've got a volume in centimeters cubed, then I just need to divide by 1,000. So if I had 10 centimeters cubed, I would just divide that by 1,000, and that would be 0.01 decimeters cubed. If I had 100 centimeters cubed, then I would again just divide by 1,000, and that would give me 0.1 decimeters cubed. So if I had something like 250 centimeters cubed, again, I just divide by 1,000, and that would give me 0.25 decimeters cubed. So normally we'd be doing it that way around, but sometimes it might ask you to do it the other way around. So if I had 1 decimeters cubed, to turn into centimeters cubed, I just times by 1,000. So that would be 1,000 centimeters cubed. So if I had 2 decimeters cubed, I just times that by 1,000, and that would be 2,000 centimeters cubed. If I had something like 0.15 decimeters cubed, again, times that by 1,000, and that would give me 150 centimeters cubed. So we can quite easily convert between the two. Now the other equation, sometimes you're asked to convert between these two different forms of concentration. So we need to remember this that we've used in the previous lesson. So N is the number of moles, M is the mass, and this is the molar mass. So that's the relative formula mass, basically, if it's an ionic compound, or the relative molecular mass if it's a molecule. I suppose if it's an element, then it would be the relative atomic mass. So it's how much 1 mole of that substance is what the mass of 1 mole of that substance would be. So let's do an example. So here's a real exam question. So a laboratory technician prepared a solution of sodium hydroxide by weighing 2 grams, so that's my mass, and he dissolved it in 250 centimeters cubed, so that's my volume, but that's in centimeters cubed, and we always have to convert that to decimeters cubed. So to convert that to decimeters cubed, I divide by 1,000, so that gives me 0.25, sorry, my point's not big enough, 0.25 decimeters cubed. And then it tells me the relative formula mass, or the MR, is 40. So use this information to calculate the concentration in moles per decimeters cubed. So the concentration, we write the formula out. So because it's the concentration in moles per decimeter cubed, the concentration is the number of moles divided by the volume, and that's in decimeters cubed. I'm just going to write that to remind myself. So I've got the mass here, so here I've converted the volume. So I've already done the volume and converted that to decimeters cubed, so that's going to be divided by 0.25. But I need to work out the number of moles on the top. So number of moles equals, so we said it was the mass divided by the molar mass. So the mass in the question is 2. The molar mass tells us in the question is 40. So 2 divided by 40 is 0.05. So if I put 0.05 on there, and then the concentration is then going to be 0.05 divided by 0.25, which is going to be, if you put that into your calculator, you should get 0.2. So our answer here is going to be 0.2 moles per decimeters cubed. Now, just a reminder, it's given us here the relative formula mass of sodium hydroxide, but if it hadn't, then it tells us here the formula. So sodium, so remember, we'd look in the periodic table, we'd look at the biggest of the two numbers. So it's got it to the nearest whole number here. So to the nearest whole number, sodium is 23, oxygen is 16, and hydrogen is 1. So I just add those up. So 23 plus 1 plus 16 equals 40. So just in case you get a question where you have to do it. And remember, if I had something like H2O, we wouldn't for a concentration question, then that little number means I've got 2. So the relative formula mass of water would be 2 lots of 1 plus 16, which would be 18. Right, so the last thing I'm going to do is just, if we were given this question, so what would it be in grams per decimeters cubed? Okay, so if I was given it in grams per decimeter cubed, just going to, sorry, excuse my dodgy line. So if the question asked in grams per decimeter cubed, it would just be, so the concentration, I'm going to abbreviate to there because I've not left myself much space, would be the mass in grams divided by the volume in decimeters cubed. So if we look in my question, the mass is 2, and our volume, we've already converted to decimeter cubed, will be 0.25. So if I divide 2 by 0.25, that's going to give me 8 grams per decimeter cubed. Now, when we put the 0.2 here, it already had the units there, but if it hasn't got the units there, don't forget to put them in. So this allows us, we can convert between concentration in grams per decimeter cubed, so that we can use this question to illustrate how to convert grams decimeters cubed to moles per decimeter cubed, and vice versa. So we've said on the previous slide that the number of moles is mass over MR. So if I want the number of moles and I've got the mass, so if we just ignore the volume unit there, if I'm going from grams per decimeter cubed to moles per decimeter cubed, I'm going from grams to moles. So I need to divide by the MR. So if I divide by the MR that way, and then if I'm going from moles to grams per decimeter cubed, I need to times by MR. So let's just prove with this question that that works. So to go from grams per decimeter cubed, which is 8, if I divide that by 40, so 8 divided by 40 gives me 0.2. And if I go from 0.2, so that's in moles per decimeter cubed. So if I want to get that in grams per decimeter cubed, I would then times by the MR, which was 40. So 0.2 times by 40 will give me 8. Okay, thank you for listening. See you next time.